He has it. So.
How many months have it been since the funding?
That was 4 hours. Are you going to start? We didn't even do it. Just held it and I didn't. That was good job.
You
can turn to page 27.
What? Let's say it music. Yeah. Say it. Come on, guys. Come on, say it.
So let me recap roots. So I really want us to practice more with roots today, and then we'll do a full review. Well, we'll begin our review process. Review Monday and Tuesday, and then test is Wednesday. So this is page 27. We did number 8. Is that right? Number 8. Okay. So let me walk through number 8 again. Anytime we have a root. Anytime we have roots, we're going to first find the radius and find theta. Okay. We want to build out our formula, so it's always going to be the 6th root of the radius, and then, but with theta, we don't raise it to a power. We multiply by that fractional value, or we can divide it by that fractional value. So once, I think it's easier to do pi over 2 divided times 1/6 than pi over 2 divided by 1/6. Or sorry, divided by 6. So 1/6 times pi over 2, 1/6 times pi over 2, we get pi over 12. And then once we have one of the solutions, we just have to figure out first how many more solutions to look for, and then also what the pattern is. Right? So in this case, 6th root, that tells us we're looking for 6 solutions. We have 1, there's 5 more that remains. So depending on whether we're in radian degree mode, we're going to do 2 pi divided by n or 360 divided by n, so that we can space out our circle into equal intervals. So in this case, it's 2 pi divided by 6, so which is pi over 3. And if I want to match pi over 3 with my common denominator, that's the same thing as 4 pi over 12. Okay. So then I take my initial solution and I just keep adding 4 pi until I reach all my 6 solutions. So 1 plus 4 is 5, 5 plus 4 is 9, 9 over 12, same thing as 3/4. 9 plus 4 is 13, 13 plus 4 is 17, 17 plus 4 is 21. 21 over 12 is the same thing as 7 over 4. Okay, so let's go through the process and try the next problem. 4th root of 4 root 3 minus 4i. So we're looking for 4 solutions. First thing, let's find our radius and our theta. For radius, we'll go through Pythagorean theorem. Theta, we'll use inverse tangents. Okay, which quadrant are we in? 4th quadrant. Okay, so we have to make our adjustments there. Okay. And right now, you may not recognize this, but you can always reduce it. Okay, -1 over root 3. We know that's going to be in the family of pi over 6, right? Y over x, 1 over root 3. Okay, we want to leave it in terms of theta, or sorry, in terms of pi. Fourth quadrant, well, we just find the 4th quadrant version in the fourth quadrant version of pi over 6, and that's just going to be 11 pi over 6. So now we should follow our formula here. Z to the 1/4 is equal to R to the 1/4, 1/4 times theta, 1/4 times theta. Okay, let me clean this up, and then this will be one of our solutions. How many more do we want to look for? 3 more. Yeah, there's 4 total. You can write it as a to the 1/4 or 4th root of 8. Just want to give you options. It's up to you. Okay, I'll box this off. I know I have 1 solution. Now I'm looking for 3 more. Right. What's the formula that can help me find the rest of my solutions? 2 pi over n. Yep. In this case, n is 4, which is pi over 2. Yes.
11 pi over 6, 1/4 or 4.
You can either divide by 4 or you can multiply by 1/4. I think it's easier to do 1/4, especially if I'm dealing with a fraction. But let's say theta was like 30 degrees, then I will do 30 divided by 4. Feels easier. If it's a fraction, I typically like to push my n out as 1/n. Okay, so to find common denominator, really I'm just adding 12 pi over 24. And I just have to go down the line and keep adding the next gradients with the pattern. So 11 plus 12 is 23, plus 12 is 35, plus 12 is 47. The hardest part of this unit is these types of problems because it takes a little bit longer than the others. And 4 solutions. Okay, any questions? Does anybody still need this page? Okay. All right, so next is it says 5th roots of unity. So unity is just another way of saying 1. And what's the complex form of 1? 1 plus 0. Yep, so just go from there. Find your radius, find your theta in terms of radians. Looking for 5 solutions. Okay, see how far you can get, and I'll work same time that you guys work. Excuse me. R is equal to 1. If I just graph this point, I can figure out what degree measure it is. I don't really need inverse tangent, right? If I just go 1 unit over to the right, that's obviously 0 degrees. So 5th root, cosine of 1 over n times theta plus I sine 1 over n times theta. 1/5 times 0 is still 0, so this is my first solution. How would I find my pattern to get to my other solutions? 2 pi over n. My n is what? 5. So I'm going to keep adding 2/5 until I reach all 5 of my solutions. I went to a shorthand form, but I encourage you guys to write it out. It just feels more complete, and that way you don't. I won't take points off if you use shorthand like this, but I think it's more. We know what it means if we write it all out, right? We don't. I think sometimes if we write it shorthand, we kind of lose our. We lose what it means. I think that 0 plus 2/5 is 2/5 plus 2/5 is 4/5. Plus 2/5 is 6/5, plus 2/5 is 8/5. We know to stop here because we're looking for 5 solutions. Yeah.
Why do you multiply it by 0? Or 0 over 5?
Oh, because first I need to find theta, right? So theta of my complex number is 0 degrees. Now, if it wasn't as easy to graph, if it wasn't on the axis, then I would use inverse tangents.
I thought we were just supposed to like 2 pi would be.
Oh, yes, yeah. So 0 is also a radian measure, right? 0 degree or 0 radians, right? Yeah, that's perfect. Yeah, I just. We start with the smaller value and we move our way up. Yeah.
So are you technically wrong? Or if it was 0, I would have added 2 pi to it, and you're still gonna have this.
You have the same thing, yeah. So, but you definitely want to include 0
Okay, instead of the 2.
instead of the 2 pi. However, well, actually 0 and 2 pi are the same. So
Right.
I start with 0 just because I can add to get to my larger value. But yeah, if you had 2 pi here instead of 0, that's equivalent. So that's fine. That's right. Yeah, you can drop that 5th root if you wanted to. You should put 1. Okay, it's a tedious process, but you guys feel okay with the steps? Okay, we'll do a lot more practice, but I just want to just see how you guys feel right now about what we've done so far. All right, good. All right, so why don't we do a full practice from everything that we covered yesterday? So if you go to page 28. Okay, find the product of Z1 times Z2 and the quotient Z1 divided by Z2. Express answers in both polar and rectangular form. It's easy to do everything in polar form first, and then you can convert it to a rectangular form. Match angle measurements. So if you start with pi, then do everything in terms of pi. If you see degrees, then do everything in terms of degrees.
Test service.
Sorry?
What's the test?
Test is going to be Wednesday. So we'll have Monday and Tuesday to review. I know Tuesday is going to be a shortened day, but we'll just and I'll also have a morning help session on Wednesday. Just for because of our lack of room here, for number one, why don't we just do Z1 times Z2? And then for number two, we'll do Z1 divided by Z2. Okay, so number one, do product. For number two, do quotients. And again, here are the rules for multiplication and division. For multiplication, you do the operation that you would expect for the R's. But for theta, you got to do plus. For division, you divide the R's like you would, like the name suggests. But for theta, you'll subtract theta 1 minus theta 2.
Are we gonna have the formulas?
No, the formulas will not be provided. Okay. But we'll do a, yeah. Maybe Monday and Tuesday, I'll have you guys practice writing out the rules so that you can kind of just get those down. Practice using your unit circle to help you get from polar to rectangular form. Multiply the radius, add the thetas. Then number 8, the same thing as 5/4. So 5/4, we recognize that, third quadrants. But we can put a box around that polar value, polar form number, complex number. And then shift over to rectangular form. So we know that 5/4 is in the family of 5/4. So all your both your cosine and sines will be √2/2, but because it's third quadrant, we know both are negatives. Any questions with one? Number 2. Number two, you'll divide the ratio, the radius, and then you will subtract the theta. All right, with this one, you kind of have to rely on the calculator again. On the test, it'll be unit circle values. Right? I know this one can't get into rectangular form without a calculator.
I could say decimal sound.
Oh, you're not getting the same decimal. Oh, you do want to make sure you're in degree mode. You are, okay.
I guess since you.
Did you multiply by 12 or 25?
Not yet.
Okay, yeah, so that's after I distributed this for I about 30.
The stuff we're doing now, like post quizzers can include stuff that's.
So if you look at the next page, that's the test review, so you get an idea. Okay, next step, number 3, we're going to convert to polar form. So this is the powers of complex number. These are easier than the roots because you don't only look for one solution. You don't have to look for all these multiple solutions. So you just find R, find theta. Okay, same process. And then you raise R to the nth power. And then for theta, you multiply by n. So exponents for radius, multiplication for the thetas. And then for 3 and 4, you're both going to be in radian form. Okay, so start with finding radius using Pythagorean theorem, find theta using inverse tangents, use your unit circle, decide which quadrant you're in. But there's only one solution. You don't have to look for all these repeated solutions like a root would. So inverse tangent of -√3/1, that's negative, that's in the -60. Now, you could have just look at your unit circle and recognize that, oh, that it's in the power of 3 family, 4th quadrant, so therefore 5 power of 3. You don't have to go through it, you know, especially if you're now that you have your unit circle in front of you, if it has to be in radians, just use your unit circle value and unit circle and just decide which quadrant you're going to be in based on which family you're under. So 5 power of 3. Raise the radius to the 4th, multiply your theta by 4, and there's only one solution, right? So no need to do the repeated solution unless it's a root, like 5th root or 3rd root or 8th root. Yeah.
How'd you get the cosine down to 2/3?
Oh,
I got like 20/3, but I didn't know how to simplify it.
right. 20/3. If you don't recognize 20/3, you can keep subtracting what to get it to be more recognizable.
2 pi.
Subtract 2 pi.
Okay.
Yeah. So 20/3 is
Is it gonna be like, can you just like cross out the 0? Is that like work,
Cross out to 0.
like for the 20, just like, cause that would be 2/3.
Yeah, I don't think so. Yeah, not, I don't think, can't guarantee that. Yeah. Okay, any question with 3? So I start with 20 pi over 3, which is outside of my interval. So it keeps subtracting 2 pi. Yeah.
Just,
That's not no problem. All right, number 4, same idea. Again, if it's raised to a whole number, then you just need one solution. It's only the roots at the bottom of the page where you gotta go through that whole process. Okay, so number 4, find the radius, inverse tangent, find your theta and which quadrant you want to be in. Okay, and we do need to subtract 2 pi if it's outside the interval because it says answer in polar form where theta is between 0 and 2 pi. So if something is outside of 2 pi, then subtract 2 pi until you recognize that theta to be between 0 and 2 pi. Sorry, so I should be writing it as cosine 7 pi over 4 plus I sine 7 pi over 4.
Is it fine if we don't put it as 32? It's,
Yeah, you can. I do prefer that you write out the whole thing because I saw last year when students used that shorthand form and down the road they just forgot what it even meant. So I won't take off points if you want to use shorthand form, but I think feels more complete. I mean, it feels like we know what every part is doing when we have that this extended form. So it's up to you, but I do encourage you to write the full form out, even though sometimes I do use the shorthand. Okay, are we good? Okay, last 2 problems. Okay, so convert each into polar form. And then we want to find all distinct roots of the complex number. Answer in polar form where 0, theta is between 0 and 2 pi. Okay, so it says 5th root of 32. Let's create the complex number of that of 32. So that's what 32 plus 0i. So I like to have that form. It just makes it so that I can graph the point. I know exactly what each of the parts are. Okay, so 32 plus 0i. If you graph that point, what's the Radian measure there. Oh, sorry, yes, the radius is 32, right, but the theta is 0, yeah, because you're just going to the right, right, that's, the theta is 0. Radius.
Okay.
Mhm. Yeah, I'll work it out.
Because we zoom down. Since we show it. Finding the circle.
You can also reduce that 32 to the 1/5. You know what that value is? What's the fifth root of 32? There's 2, yeah, so you can write it as 2 if you want to reduce it. That's fine. Okay. How many more solutions do we want? 4 more. Okay. What's our formula? 2 pi over,
32.
not over 32, over n. What's my n value? 5, yeah, so, yeah, your n is gonna be however many solutions you're looking for. Yeah, 2 pi over 5.
So it's cosine 0 plus I sine 0 plus 2 plus. Oh,
Yeah, that's my first solution. Okay, yes.
But okay, we did it in degree mode. Or like, instead of in like 60 degrees.
We want to, yeah, we want to follow whatever they tell you, then you're going to follow. Yeah, so it'll be very clear what you want to do things. Okay, for number 6, 4th roots of negative 81i. Can I put that into full complex form? 0 minus 81i. Yeah. Easy to find the radius just by looking at this. You can tell what your theta is.
81.
Yeah, because I'm going down, right? I'm just going down. Yeah, but radius is 81, but your theta will be 3 pi over 2. You're going down.
I think it just is good.
So think of this as your order pair, right? So if I were to ask you, how would you graph 0, -81? It would be down on the y-axis, right? Which is 3 pi over 2.
Oh,
Yeah, think of your first number as your x, think of your second number as your y. Now, if it was not on the axis, then I would rely on inverse tangents because it's not easy to find. That's easy to find. Leave it as 4/3 of 81, or you can reduce it down to 3. So that's one of my solutions. I need to find 3 more. My pattern is 2 pi over 4. Yeah. So 4 pi over 8 would be my common denominator. So 3 plus 4 is 7, plus 4 is 11, plus 4 is 15. Okay, all right, so we'll do full test review Monday. Some more review on Tuesday and then test Wednesday. Right, don't get your phone.
Are we gonna have this? This one,
It's this test review, but I have a separate one. All right, let me get your phone.
Yeah.
So there's the E for the test review and also a second test review with the.
I actually can share. Makes sense. Have we said it?